Welcome to Limits at Infinity. So the idea here, in pre-calculus and earlier classes, you likely studied end behavior of a function. Um, so you've likely seen end behavior of a function. So in this case, we're essentially going to study as x goes to negative infinity or positive infinity, what is happening to f of x. So as x goes to either positive or negative infinity, what happens to f of x? So for example, let's consider the function f of x equals 2 to the x. So if we graph f of x equals 2 to the x, 2 to the x is always positive. For negative exponents, that becomes a fraction and the denominator gets larger and larger as we go more negative. We approach the x-axis. When x is 0, the function is 1. And then as x gets large, the function grows on forever. So in this case, what's happening, if we trace that graph, as x goes to negative infinity, as we head our way to the left side of the number line, our graph is getting closer and closer to y equals 0, but never actually touches. But it certainly looks like our graph is essentially heading towards 0. Right? So again, what we have is as x goes towards negative infinity, the y value gets closer and closer to 0. On the other hand, if we look at what's happening as x goes to positive infinity, our y value is just getting larger and larger and larger, and it looks like it's going off forever towards infinity. So in this case, the limit as we go towards positive infinity is considered to be positive infinity. Again, as x goes to positive infinity, y gets larger and larger. Heading towards infinity. So let's go ahead and look at another function. So the function g of x equals 1 over x. This function is undefined when x equals 0. If we're close to 0, dividing by smaller and smaller numbers, our fraction winds up being larger and larger in the end. For positive x, we're positive. And then as x gets large, our fraction will get closer and closer to being equal to 0. And then on the negative side, 1 over x will be negative, and it will shoot off to 0, going to the left, and negative infinity as we approach x equals 0. So in terms of our limits, as we head towards negative infinity, we're approaching the x-axis, so we are approaching y equals 0. So once again, we get 0. And we have as x heads towards negative infinity, y heads towards 0. And then so we head towards positive infinity, the same thing is happening. So in this case, again, we're heading towards 0. So as x heads to positive infinity, our y value is getting closer and closer to 0. So this is essentially what we're looking at as end behavior.